So, here's our new one. You guys like it, right? You know, very quick, very easy. Step 1, H naught is mu1 equals mu2 equals mu3. H1 is at least one differs. Step 2, alpha equals, what is it? 0.05. Great. Step 3, stat test ANOVA, L1, L2, L3. This is L1, this is L2, this is L3. And you guys got F equals, what does F equal?
5.035.
And p-value you said was 0.0212. Great. So then step 4 is going to be reject H naught, and you have to say why. Because p-value
0.0212 is less than
alpha
value alpha 0.05.
0.05 alpha. Make sense?
So what exactly is that F value?
F value is the between variance, right? Between group variance. So you have the little guys, the big guys, the between group variance divided by the within group variance.
Okay, so it really doesn't matter like what the F value is.
Well, if it's close to 1, then you would not reject. If it starts getting further away from 1, then that's when you're going to reject.
If we have a
If
table,
you had a table,
we will use that.
Would be using it.
Yes.
Oh, okay.
Yeah.
If we
So
have
if we had it, if I gave you yet another table, you look at that table and you draw a picture and you see if it's further away or not.
if it's in the critical region or not.
So it's your test stat. Okay, good. And then the very last thing is going to be enough evidence to say means differ. Good? Great. Now, there's a couple things I want to go over with you guys. We'll do the last one later. Here is just the very quick summary of the steps for ANOVA. So you guys are good with that?
Yeah.
Right? State the hypotheses, that's what it's going to be. Find alpha, compute the p-value, make your decision, and summarize your results. Now, this problem will do later. I want to talk about this one right now. We have covered 5 sections, which includes 4 different tests in chapters 10 and 11. You need to figure out how to tell them apart. There's some really good visual ways of doing that. There's also some other ways of doing that. I'm going to talk about this way first, and we'll do the visual way in a minute. So first of all, you have 2 different variables, not 2 categories, but completely different variables, like casino size and revenue. Are casino size and revenue 2 categories of the same variable?
No.
No. Are SUVs, sedans, and small cars different categories of the same variable?
Yes.
Yes, you guys see that?
Yeah.
So if there are 2 different variables, then we're looking for a relationship between them, a correlation between them. Then that's the first thing, chapter 10, correlation and regression. Everybody see what I'm saying?
It says so too, right?
Visually, they'll also be matched up as points, x and y points. So the points will be matched up together. You guys remember how those, and you can make a scatter plot, right? So that's the other thing. So they'll have points. Pairs of points. The other possibility is that we have categories. So different categories of the same thing, and how many are in each category. Right, we're talking about frequencies. We have observed and expected that we're comparing. So that's going to be, so it'll either be a bunch of categories and just a line of observeds, and you have to figure out the expecteds. So that's not lists, it's just categories, but not lists. If you have categories and lists, that's going to be what we just did. If you have categories and just one number below each one of them, right, for your observed, and maybe another line below to fill in your expecteds, that's that first one, 11.1. If you have categories all across the top and categories along the side, and you have this contingency table with frequencies inside of them, then that's going to be this matrix, the chi-squared matrix.
Okay.
Everybody see what I'm saying? The last one, like we talked about, is this, if you're talking about multiple lists and their means. The things in the lists are numbers, which could be decimals, right? They're numbers, they're actual physical numbers. They're data. And again, you have categories across the top or categories alongside, but not both. And a list of numbers, right? Categories here, list of numbers, but nothing up here. Or categories here and lists of numbers, but nothing over here. Yeah.
But the easy way to tell between 1 and 3 would be that 3 is always going to have 3 lists compared to like.
A 3 or 4 could have more.
Right, and one's only going to have 2 together.
Oh, yeah, it's a good way. Yeah, so one good way of comparing between this one and the first one is the first one's only going to have 2 items, right? Points. But the different variables. So don't confuse them with a chapter 9,
Yeah,
right? But yeah, because they're 2 different variables. Yeah.
be good.
Yeah, but that's a really good point. Is that this one will have 3 or more lists, absolutely, totally. Good. Everybody kind of on board with those parts? Okay, so this is 11.3. Okay, we'll talk more about that next. Yeah, question about it?
Not about this, but I just have some to do. So today's our last Tuesday class, right?
Yes.
Okay. And then also, is the grade that's like shown on tonight's math, is that our actual
That's
grade?
your current grade,
That's
yeah.
current,
As
okay.
long as it says all, and you haven't clicked on tests or whatever.
Okay.
Then yeah. So again, we have our last class is on Thursday. Bring foods or food or something to drink. And then Tuesday we don't have class, but I'm going to be doing a review session, which you're free to come. Okay. Great. Good job.